We are resuming the lesson on radian measurement, focusing on converting between degrees and radian measures. The previous lesson, we discovered how to convert radians to degrees, degrees to radians, and also the arc length. For today's lesson, I'll review your assignment questions, which is check your understanding question on page 489. So I'll be reviewing So check question 1 on page 489. And also your assignment practice questions on pages 494. So questions 5, 6, 8, and 9 on pages 494 to 496 of your textbook. So today we'll be focusing on converting degrees and radians measures, degrees to radians, radians to measure, and also finding the arc length using the formula, which is A is equal to theta R. So that's your whole formula we do. And also we discovered the concept of radians and degrees. So let's start with the first question, which is check your understanding. So you're given theta at 170 degrees, determine its measure in radians, give the exact measure and its approximate value to the nearest hundredths. Part B, you're given theta is negative 12 pi over 11 radians, sketch the angle and center position, determine its measure to the nearest tenth of a degree. And the final part, given theta equals 7.5 radians, determine its measure to the nearest tenth of a degree. So let's start off with part A. Now, just if we were to review some of the things we've learned before, we know that 1 radian is equal to 180 degrees over pi. We know that 1 degrees is pi over 180. And we know that pi radians is 180 degrees, and 360 degrees is equal to 2 pi radians. Also, we know that you can find the arc length. Oops. So that if we know the arc length is equal to theta times the radius, and theta must be in radian. So we'll utilize these 4, 5 facts. Okay. So look at the first question now. Given the measure of, so we know that since just a little bit so you can now since 1 degree, as we know here, is equal to pi over 180 radians here. Then 170 degrees will be equal to 170 multiplied by pi over 180 radians. Comes out to be, what would that be, 17 over 18 pi radians, which is equivalent to, let's see what that'd be. So we have 17 pi divided by 18, 2.97, which is approximately equal to 2.967 radians. That's the first part. Zoom out a little bit here. So we're using these facts here. So converting now, here you're converting degrees to radian. And the easiest way to remember it, right? It's like you'll know that degrees will factor out. If you had it the other way around, you have 180 degrees over pi, you'll notice it will not factor out. So let's go on to the next part, which is given negative 12 pi over 11 radians, sketch the graph. So you want to change this in degrees. So you take the radians, so let's go to the B part here. So convert radians, or I should say 12, negative 12 pi over 11 radians to degrees. We'll put the graph here. So we have negative 12 over 11, right? Multiply. Now we want to change, if we're converting radians to degrees, we will want this to be divided by 180 over pi. Notice the pi will factor out. And we're left with negative 12 times 180 over 11. Now, what will that be? Give us negative 12 times 180 divided by 11, negative 196 degrees. Negative 196.36 degrees approximately. So now we going, remember, if we're going counterclockwise is positive angle, clockwise is negative, so we 180 degrees. So 109, so pi. So that would give us negative 12 pi over 11. So this is negative 12 pi over 11. So my circle, the last part, given theta 7.5 radians, determines measure to the nearest tenth of a degree. And we'll repeat the process. We'll see. So since 1 radian is equal to 180 degrees over pi, 7.5 radian is equal to 7.5 multiplied by 180 over pi radians. Now, let's get my calculator out here. So 7.5 multiplied by 180 divided by pi equals 429.72 degrees, approximately. So 7.5 radians is approximately 429.72 degrees. Now, the setting having you a 1/10 of a degree, so I need to round this up. So it'll be 430.0 degrees. Because the question was to make it into a 1/10 of a degree. I guess I should have done the same thing here. This should be negative 196.4 degrees. So that's converting angles, which seems quite straightforward in many ways. So we'll continue to use these. Now, if you go to the next set of questions from your. Now, I would. These are easily sketched. Pi over 4 is at 1/3. So you can convert these to degrees, but you don't have to. Let's look at the first one. Now, this would be, if you were to look at a unit circle, this is 0 degrees here, or radians, so it'd be pi over 2 pi. Oh, this is 1.5 pi, or 3 pi over 2, and you have 2 pi here. It's a complete circle. Obviously, then the reverse would be through, negative, etc. So pi over 4, which is a quarter, right? 1/4 pi. So notice, right, this is 1 over 4 pi, a quarter of a pi. Now, pi is just half of a circle. So if you were to do this now, this would be a pi over 2 here. So this would be pi over 4, which we know is 45 degrees. Now, 5/3 pi, no, this is just a little more, this is more 1 2/3 pi. You can just 1 2/3 pi. So 1 2/3 pi, this is 1 pi is here. Now, down here is 1.5 pi. So 1 2/3 pi would be over here. And you can resume it pi over 6, which is negative now. That's negative 30 degrees. So that would be approximately here, negative pi over 6. Or 1/6 of a pi. So follow through half a pi would be 90 degrees. 3/4 pi would be 3/4 of 180. And the negative would be the other one. So just sketching those as practice questions for you. Now convert degrees to radians. So we all practice this. Any one of these to angle to radians. So degrees to radians. You take your degrees and multiply it by pi over 180. So this would be 60 times pi over 180, 70 times pi over 180, and this would be negative 450 times pi over 180. So this would give us pi over 3. This would give us 4 pi, and will this be negative 5 pi over 2. convert each angle to degrees. So remember when you're converting to degrees, so we have radians. You take your radians and multiply it by 180 over pi. So we have 7 pi multiplied by 180 over pi. The pi factor out 1. So you have 7 times 180, which is equal to 1260 degrees. You have 5 multiplied by 180 over pi, which works out to be approximately, now what would that be? 5 times 180 divided by pi gives me 286 degrees approximately. The nearest degree to tell you here, so this would be 286 degrees. Now we have negative 5 pi over 6 multiplied by 180 over pi. Pi will factor out, and this works out to be negative, what, 150 degrees. Now, question 6, determine the value of each trig ratio to nearest 100. You'll need to use your calculator, and whenever you're using your calculator, make sure you're in radian mode. If you're in degree mode, you have a different number. You're simply working in degrees, not in radians. So for example, now let me make sure I get my calculator in radian mode here. Yes, I am. Okay. So cos. Okay. So what I meant by that, if in this graphing calculator, maybe I'll put it over here, of steam. Okay. I have to put mode and then make sure I'm in radian mode, not in degree mode. I'm going to find cos. So whatever you do for this case, you press your cos button and pi divided by 10, give a result of 0.95. So approximately. So we do sine 2.5, approximately 0.59. Now the one for the hundreds, so I need to stop. 0.60. So ask you for the nearest hundreds. Now cotan, in your calculator, remember cotan is 1 over 10, right? So we have 1 over 10 negative 3 pi over 5. So we'll have 1 divided by 10 negative 3 pi divided by 5. Close bracket. 0.32. So this is approximately 0.32. So question 7, sketch each angle in radian and standard position. Now, a measure of 1 radian is approximately 1/6 of the circumference, right? Because 1 radian, remember we said that 1 circle is equal to 2 pi radian. So if you have 1 radian, so 1 radian is 1/6 of a circumference. So we have, so if you look at divided by itself, so 1 radian is 1/6 of the circle. So if you were to, which is approximately 57 degrees, 57.29 degrees. So that's 1 radian. So 2.4 radians. So now we have, think of a 1 radian. So we have 1 radian to 7 degrees. So we have like 2.4 radian, which will, oh, this is not. So here we have 1, so 2, we double this, would be approximately, what, 57? So we have 2.4 times 57 approximately, which is 136 degrees, which is about right there. 2.4 radian. Now, -4 radian. So you're going down. So we have, start from here. So we have 1, 2, 3. So 4 times 57. Now let's do that here. 4 times 57 is approximately 228 degrees. So it would be approximately here. And this is 180, -180. Now, 7.5 radian. So now you're more or less going around with negative, you say. So this is approximately 6. 7.5 about here. And you can have that up 7.5 times 57, 427 degrees. So we already have 360 here. And then we add another 47.50. So we have minus 360. We have 67 degrees. It's approximately here. Okay. Now this is the part now. Oops, sorry about that. We have to use our arc length. So we said that arc length is equal to theta times the radius. So A is equal to theta r. So here I give you, determine the length of the arc that subtends each central angle in a circle with each radius. So here is your central angle, which is 3, and your radius is 4. So A is equal to the central angle times radius, which will give us, so arc length, which is 3 multiplied by 4 centimeters, which worked out to be 12 centimeters. So here we have length. Equal to theta times r, which works out to be 1, because it's the radius. That's your central angle of 1. and multiply by 5 centimeters, which work out to be 5 centimeters. Continue. Arc length is theta times r. We have 4, pi over 4. Zoom in here. So the arc length, so already, is equal to pi over 4 multiplied by 6.5 centimeters, which worked out to be approximately 5.1 centimeters. Here we have theta times r equals a. So 3 pi over 2 multiplied by 2.5 centimeters. Now, I haven't worked this out. Now I have to do this work right now, which is 3 pi divided by 2. Then multiply that by 2.5. Give me an answer of 11.78. So, which is approximately 11.78 centimeters. Now, one last question here. And that will be the end of the review for looking at arc lengths and converting degrees to radians. So you have an arc length of 2 centimeters with a circumference of a circular radius 3. So the arc length divided by the radius, right? So the angular measurement, so we can say the angular measurement will be equal to the arc length divided by the radius. So it's like you have a circle here. Let's visualize an arc length 2 centimeters. So we have 2 centimeters here. This is my radius. And the radius of 3. So we need to find a central angle. Remember, I'm simply converting this, right? So if you look at this equation here, we have A is equal to theta over R. We need to find theta, so theta is equal to A over R. Arc length divided by the radius. Okay. And the last one, maybe I'll just throw this out here, but you can have to try it now. Now, the area of a sector of a circle is proportional to the central angle. Right. Determine the area of the sector of the circle formed by the arc and the radii that intersect the endpoint of the arc. So the area of the sector says here, area of the sector of the circle is proportional to the central angle. So the area of the sector divided by the area of the circle, because they're proportional. Now we know from here, okay, they told us here from that the angular measurement is 2/3. But we didn't work it out. No, we did not work it out. Okay, we need to work this out. 2 divided by 3. Or 0.7. So the angular measurement. So the area of the sector is equal to the angular measurement divided by 2 pi. So we have 2/3 area of the circle, which is 2 pi. So this is the area of the sector divided by that. And so that will give us, so the area of the sector now, divided by area is CL. So the area of the sector is equal to 2/3 over 2 pi multiplied by the area of the circle. Which is 2/3 over 2 pi. Now the area of the circle is pi r. Now the radius is 3, right? Which worked out to be 3 centimeters. When you do all of this here, it's worked out to be 3 centimeters squared. Okay, that's the end of the questions related to the first converting degrees and radian measures and arc length. Our next lesson, we'll be looking at determining the trig ratios of angles in radians.